Welcome back, boys and girls. So today again I'm going to discuss the next points from your learning objectives from the book, AP Chemistry book. These are, I'm focusing 2.3. We discussed already the calculation of mass number in isotopes and all the other relevant information related to the isotopes. We discussed all this, and in this video I will try to cover rest of the parts of the book, rest of the part of these learning objectives. For example, recognize the general organization of the periodic table with respect to metals, metallites, non-metals, groups and periods. Differentiate between molecules and ions, and will try to learn about the classify chemical formulas as either molecules or empirical, or molecular or empirical. Determine the formula of ionic compounds and some of the rules for naming the compounds. Okay, so proceeding. Previously we discussed all these, and hopefully you understand. If you have any question or you didn't understand these, please refer to the previous video. I will post the link in the description. So right now I'm going to discuss the next part. The first one is the periodic table. We are trying to learn what is periodic table and what are the main families, the groups are present in that. Okay, first of all I'm going back to your chemistry, AP Chemistry book. There you can see so this is your AP Chemistry book, and I will show you this is in present. This periodic table is at page 50. Okay, so you can easily see we see three colors mainly. First of all, try to learn in this periodic table we have mainly two things here. First is these are the horizontal rows. You see, these are what? Horizontal rows. This one, this. So these are what? Horizontal rows, and these rows are called as periods. These rows are called as periods. So these horizontal rows, they are called as periods. So for example, this is period 1, this is period 2, 3, 4, 5, 6 and 7. There are total 7 periods. Okay, next you can see these are columns. These are vertical columns, and remember there are mainly 8 groups. Okay, so remember these vertical columns are called as groups, and the numbers are already assigned: 1A, 2A, 3A, 4A, 5A, 6A, 7A and then 8A. Furthermore, they are numbered like this: 1, 2 starting and then ends at 18. But remember that starting from here 13, 3A, 14, 4A, they are all same. If you say 13 or 4, it has the same meaning. But so remember, these are called as groups. So these are called as groups, or sometimes families. Next thing is in between group 2 here, group 2 and group 3, or either you can say between group 2A, 3A, group 2 or 13, there is a block. This block of element is called as transition element. This block of element is called as transition metals or transition elements. So just now you have to memorize the names. What are the periods? What are the groups? Next thing is we have to divide this periodic table into two main groups. What are these two main groups? Starting from boron and aluminium, because in your exam you are provided with the blank copy of the periodic table, not the colored one. Okay, So you have to identify where the metals are and where the non-metals are. So draw a line between boron and aluminium and then extend it like a stair. In this way, you can easily understand that periodic table is divided into two parts. All the elements which are present to the left side of this staircase, they are all non-metals. They are all non-metals. Whereas all the elements which are present to the right side, they are all metals. Next thing, the elements which are touching this staircase except aluminium. Other than aluminium, all the elements which are touching this staircase are metallites. Okay, or metallites. So one more thing, one important thing, that metals always lose electrons. Metals always lose electrons. So they will form a positive charge ion, whereas non-metals always gain electrons. Remember that non-metals what? They gain electrons. So they behave oppositely. Understood? So metals always lose, whereas non-metal always gain. These two rows, they are part of these transition, but due to some different properties, they are not called as transition, and that is why they are placed separately. Okay, so you can see there is a gap. There is gap here. So actually this line is placed over here, starting from 57, ends at 72. So you can see the elements missing are 58, which is here, and 71, which is here. So starting from 58 to 71, they must be placed in between these two elements, whereas the elements starting from 90 must be placed between 91 and 104. So you can see this is the lawrencium 103. So these two lines are actually the part of this bunch of the elements, but due to some change in the properties, they are not listed there. Okay, but they are still metal. They have a tendency to lose electron. So this is the simple or little idea about the periodic table. Now go one more thing. This is page 50, and you can easily find out all the information related to the metals and non-metals and how periodic table is arranged, but this is not directly the part of syllabus. You just know that what are metals, where they are located, that's it. What are non-metals and where they are located. What are metallites and where they are located. There are some more families and groups, like for example, if group 1, we are talking about group 1. These group 1 are called as alkali metals. These are called as what? Alkali metals. Whereas the group 2 elements are called as alkaline earth metals. These are called as what? Alkaline earth metals. Then the noble gases. The noble gases, group 8 or group 0 are called as noble gases, and group 6 is known as halogen. Is known as what? Halogen. Group 7. Got it? So just remember these information and the position of the transition. That's enough. Okay. So next thing is we have to discuss about the molecules and ions. So first question, what is ion? Remember that ions are the elements, ions are those atoms which are involved in losing electron or gaining electron. So I'm going to write here because now this is important point. Ions. What are ions? So simply you can say when atom involved in losing or gaining electron. When atom lose or gain electron, it becomes ion. If it is losing, if atom lose electron, it becomes positive charge ion. Positive charged ion called as cation. For example, sodium belongs to group 1. It will easily lose electron and will change into a sodium ion. Okay, when losing electron, it will change into a sodium ion. Similarly, the calcium belongs to group 2. It can easily lose 2 electrons. It can easily lose 2 electrons and change into calcium 2 plus charge ion. Got it? By losing 2 electrons. Same is the case of all other metals. How many electrons are they losing? They will have a charge equal to the number of electrons lost. Next thing, if atom gains electron, which are usually non-metals do, okay? If atom gain electron, it becomes negative charge ion, negative charged ion, also called as anion. But remember, you should be write it combined way, anion. Okay. For example, if I say chlorine, which gains 1 electron, when it gains 1 electron, it will change into a chloride ion. Another example, if I talk about oxygen, it gains 2 electrons because there is a deficiency of 2 electrons. It will acquire a charge of 2 negative and its name changes with IDE. So this is the simple difference between a positive charge ion and a negative charge ion, that the positive charge ions no need or they are not ended with the letter IDE, whereas the non-metals always, when the non-metals change into ion, their names changes and they will end with IDE. For example, this was chlorine, now it is chloride. Now it is chloride. Before this was oxygen, but after conversion into the negative charge ion, it will change into oxide. It will change into, or it changes into the oxide. Just remember that. Okay, so this is simply about the formation of oxide and how the oxides are formed. Got it? So now I'm going to show you from your book. There is a simple position of the or the charges of the ion. How you gonna figure out these? So you can see from this, if you successfully remember the charges of only these, you will be able to write down max number of formulas which are required in your level. Okay, so remember, no need to memorize sometime. Group 1 always lose 1 electron and acquires 1 positive charge. Group 2 always lose 2 electrons and acquires 2 positive charge. Just release or just ignore these transition and straightforward moves to the group 3. Group 3 always lose 3 electron and acquires a 3 positive charge. But the metals from group 4, they sometimes lose 2 electron and sometimes lose 4 electrons. Just remember that. And then now out of these transitions, if you successfully remember the iron, the copper, about the zinc, that is more than enough. Okay, or if you memorize all these, then you will be very comfortable in naming all of the compounds. But just remember, when we try to draw the structure or write the formula and write the name, we must have to mention what type of the cation, what type of the transition metal ions we used in making the formula of the compound. I will show you in some examples. Okay, for non-metals, just remember group 7 requires 1 electron and they will gain 1 electron, becomes 1 negative charge ion, all of them. Okay, they all have 1 negative charge. Group 6, they always gain 2 electron and acquires 2 negative charge. Same is the case with group 3 and then group 4. But mainly focus on these 3 groups, 17, 16, 15, or group 7, 6 and 5, whatever you are calling it. Now time to learn about some of the complex ions as well, and also remember what is complex ion. Okay, so I'm writing here complex ion. What is complex ion? Sometimes it is also called as radical or compound ion or compound ion. Okay, so what we are going to do here in complex ion, just remember this is what a group of atoms, a group of atoms which are involved in electron losing or gaining. Okay, so they will become a complex ion or a compound ion, a group of atoms which are involved in electron gaining or losing or gaining becomes radical or complex ion. For example, there are multiple, and I say these are total in 12 or 13 numbers. If you remember all these, you will be very okay in formula making. First of all, I'm talking about the single particle which has a 1 plus charge. It is ammonium ion. It is ammonium ion. Formula of the ammonium ion is NH4. Remember, this 4 is the part of the formula. You are not supposed to remove or displace this number with 1 plus charge. So this is the single complex ion which has a positive charge and which we will use more frequently actually. Okay, that's why I'm saying single one. Rest of all complex ions which we use most or more frequently have negative charges. So the next one is hydroxide ion. Hydroxide ion. This hydroxide ion has the formula OH, O capital, H capital with 1 negative charge. Then nitride ion with the formula of NO capital 2 1 negative. Nitrate ion. Nitrate ion, the formula is NO 3 1 negative. Then hydrogen carbonate. Hydrogen carbonate with the formula, sometimes also called as bicarbonate. Okay, the formula is HCO3 1 negative. Last, from raw, remember there are multiple, there are many. Okay, but if you focus only these, you will be okay with formula making. So this is acetate, CH3COO 1 negative. The name is acetate ion. Acetate ion, or sometimes also called as ethanoate ion, or sometimes called as ethanoate ion. These are the charges, these are the complex ions with 1 positive charge. Now to discuss about 2 negative. These have 1 negative charge all. Okay, so now 2 negative. Most important is carbonate. Carbonate ion with the formula CO3 2 negative. Sulfate sulfide first. Sulfide ion SO3 2 negative. Sulfate with the formula SO4 2 negative. Then thiosulfate. Thiosulfate ion Remember, these are all ions. So this is S2O3, S2O3 with 2 negative. Lastly, with the 3 negative, and these are phosphide ion with the formula PO3, charge 3 negative, and phosphate ion, formula PO4, 3 negative. So my advice, if you memorize all these, it will be very convenient for you to write down main formulas very easily. Okay, so right now I'm giving you a few examples, and then I'm closing the video. Okay, so how, just to write down the formula of ionic compounds, what you are going to do, select any cation. For example, I'm taking lithium. Lithium belongs to group 1, that's why it has a 1 plus charge. And I'm taking one anion. For example, I'm taking fluoride with the symbol of F and 1 negative charge. Now recall that why they have these charges. Lithium belongs to group 1, that is why it has a charge of 1 plus. Fluorine belongs to group 7, requires 1 more electron, has a 1 negative charge. So what to do next? Just combine these two symbols LIF and then cross these numbers. This number should be written over here, and this number should be written over this position. So when I do so, this one and this one. Now remember that if the numbers are same, no need to write them. If the numbers are same, or if the numbers is 1, then no need to write that number. So final formula should be LIF. Lithium, this is the name. The lithium ion has the name of lithium, whereas the fluorine, when it changes to a negative charge ion, ends with IDE. So the formula name will be lithium fluoride. Lithium fluoride. Understood? One more example. If I take potassium, or if I'm going to take magnesium, okay, the symbol for the magnesium is Mg, and because it belongs to group 2 of the periodic table, it has a 2 plus charge. Now this time I'm going to take sulfur. Sulfur belongs to group 6 of the periodic table, has a 2 negative charge. When I combine, as I clearly mentioned, if the numbers are same, no need to write them. That is why the final formula should be the number 2 number here, this 2 comes to this position, but as the numbers are same, we are not going to write them, so it should be MgS, magnesium sulfate. Magnesium sulfate is the name. Magnesium sulfate. Understood? So these are the namings. And now if I take some complex example and one example from transition, then it will clear all. So for example, again now I'm taking calcium with 2 plus charge, because calcium belongs to group 2. Here this time I'm taking nitrate ion, NO3 with negative charge. Now to remember, this 3 is the part of the formula. You are not supposed to relocate or displace this number. What you are going to do, just combine, as we learned previously, CaNO3. Both of the cation and anions are combined. Now the numbers are crossed. This number should be written at this position, so it will be 1. And this number should be placed at this position, okay, 2. But as this 2 is making confusion, what we are going to do, we have to use a bracket to confirm where or what is the exact position of this 2. So final formula should be Ca in bracket NO3 whole twice. Why? As I said, no need to write 1. No need to write 1, and no need to write the numbers if these numbers are similar, like 2 and 2, then we are not going to write them. So the name will be calcium or calcium nitrate. But if I am going to use the element with a dual charge, for example, iron has two charges. In some of the compound it shows 2 plus charge, in some of its compound it is going to use 3 plus charge. So if I combine both of them with the oxide, okay, if you see iron 2 is combined with oxide ion, and if iron 3 is going to be combined with oxide ion, what should be the procedure? What we learned previously, just combine them, Fe2, cross the numbers and O2. But as I said, the numbers are same, ignore them, no need to write them. So the final formula should be FeO. Okay, but in this case, when I do the same procedure, the formula should be Fe2O3. The numbers are crossed, okay, but now the formula is different. We are not going to ignore any number. So now it is very clear. If I am going to write the name iron oxide for this compound, and also because it is iron as well, iron oxide for this compound, so it will definitely create a confusion. Either examiner is talking about this formula or examiner is talking about this formula. To make it very clear what type of the iron ion we used, we must have to include a Roman numeral to indicate the charge on the ion. For example, 2 in this case. So it confirms that we are, or examiner is just requiring this formula, not this one. And if I require this one, then it must be written Fe3. So this 3 Roman numeral indicate the charge. This 3 Roman numeral indicates what? Indicate the charge or valency or the oxidation state, whatever you say, on ion, on cation. Understood? So remember that mainly these Roman numerals are used when we are making the formulas from the transition ions or those metal ions which have more than one valency or more than one charge. Hopefully you understand that. Okay, so in next video I will try to cover the formula making of covalent molecules and try to finish the rest of the part of the learning objectives. Take care.